This is the third time I've tried to record this. Hopefully the video works fine for this. So this is day 4 of Advent of Code 2025. And I think I'm going to break this into two parts. The first part is really going to be about thinking in iterators. I'm going to go through a higher level description of what it is that we're doing here and solving this using iterators in Rust. And iterators, I think, is one of the most powerful features of Rust. It simply changes the way that you think about writing software. And you can look at that just from this very first one, where we get the first argument. So args is a an array of arguments, the argv list in your on your command line. So we get the nth argument, and we use OK or else to sort of short circuit the operation here with this question mark operator at the end to error out if we do not get the nth argument. So there's a lot going on here. We are getting the sort of array or list of arguments. The iterator system is getting the nth one, which just means, get the 0th one, which is your command line or your program, and the next one, the first one, is going to be the argument that I want, and we're going to error out here. So a lot of work happening in very few statements here. There's no if checks, there's no loops. It just it unrolls that, and actually it inverts your for loops. Read file is a common library that I have. Read file just reads to string, returning result type so that I can error out quickly. Parse data into grid. I have a grid library that I've written that allows us to parse and return a rectangular grid of values. And in this case, the value is going to be cell. Our cell here is either going to be an empty cell or a paper cell. The parse routine here is going to rely on from stir of the inner data type that we use to be able to parse a character value, really a single character string, into the data type that we're looking for. So this one line here with this implementation right here allows us to parse the data that we have into a grid. And then we run part 1 and part 2. Let's look at part 1. So part 1 uses the cells method. Now, if we look at the documentation for cells on grid, it says it's going to return an iterator over all the cells in the grid. So we have this iterator of things, and the item in here is a cell in a grid. So a cell in a grid is sort of um, a wrapper type that says, here's the cell value, here is the grid that it is, here's the XY location of it. It allows you to traverse and walk through a grid from a particular location. So we get all the cells. And if we just read this, let's just read what we have here. These are all the cells. Now we should note that this is not actually like a vector. This is kind of a future iterator that says when we do walk through this, we're going to get all the cells of the grid. We filter the cells based off of whether or not it is a paper or not. So we're getting all the cells that are of value paper. And filter is the one of the iterator combinators that allow you to filter based off of a predicate here. In this case, is paper just says, hey, is our cell value paper? If it is, then it uses it. The next statement is we're going to filter again. We're going to say, well, let's only get the accessible paper cells. So we take all the paper cells and we filter again. That's just another, if statement that's going to be applied to every value. And we are filtering it based off the predicate of whether or not this cell is accessible. I'm going to drill into that in just a second, but let's look at the rest of it. Let's just assume that that works. That is accessible. We'll properly check to see if a cell is accessible based off of our criteria. And then we just get the number of accessible paper cells and we call count on this. So only at this point on line 25 does the system actually iterate over all of the cells and apply this sort of predicate machine on top of it. So this is how you can see how it turns our iterator, our for loops and our conditional checks kind of inside out. And then we just print it. And part two does a very similar sort of thing. Basically, we end up with the same sort of accessible paper cells. We have these same three filtering mechanisms that we have here, except for all the cells, we extract out the XY location, collect it into a vector. And we do this because we need the grid to be mutable. It's dealing with a borrow checker to make sure that this works. And then we just remove all the cells and we do it again. And we just count those up. So like our algorithm side, our like business logic side is very clean. So what I do want to look at is accessible. So is accessible is also very clean. We say, okay, for the cell that we're in right now, and I mentioned that this cell and grid allows us to walk from where we are to something else. So quite often in these problems, we need to do some sort of pathfinding. We are at one cell and we need to look around us to make some sort of determination of what we're going to do next. So adjacent cell, according to the documentation, returns an iterator over all the adjacent cells of this, including the diagonals. So it returns another iterator of additional cells in the grid. So if we were, well, if it looked like this, so if we were like here on our, there we go. If we were here where my cursor currently is, it's going to return all of these locations here, including the diagonals. If it were here, where we're like, we don't have some adjacent cells around us, it's only going to return the left, down, and the down values. There's only going to be three. So this will properly do all of the boundary checking to only give us the adjacent cells. So of the adjacent cells, we filter that based off of whether or not the adjacent cell is a paper. And according to our spec, it says a cell is accessible if it has less than 4 adjacent paper cells. And that's what this last statement is. Cool. So that's all I want to show here. The next video is we're going to drill into it a little bit more. I want to look at, actually, I'm going to implement grid sort of for us. In particular, like how we go left, right, top, bottom. So, and what's cool is like there's basically no for loops and there's no if checks. And we can do this all with the option, result, and iterator systems that we have available in Rust. So that's a quick walkthrough, and watch the next video if you like this, or watch it if you don't like this. I don't care.